Hi, my name is Lucas Kramer, and this is my BBE 2201 DSARI project. And for my project, I built a solar-powered security light essentially from scratch. And I designed to switch on a solar-powered spotlight for a few minutes whenever a motion detector is triggered. And they set a budget goal that cost me approximately $50 or less. And it ended up being a little more involved than I expected, since I ended up putting in more than 28 hours instead of 15. Yeah. So my motivation is that even though a small non-solar security light doesn't use a whole lot of power, it does add up eventually. I'll talk about that more in the energy calculations section. And a solar light gets around this problem because it uses energy from the sun. But the only problem is that most cheap, like less than $50 solar security lights that I found had drawbacks, like they're not bright enough, or not sensitive, or not reliable, or their reviews didn't look very good, or other problems. And so, to get around this, I'm building my own solar security light basically from scratch. And so, design. So, I decided to modify an existing solar-powered spotlight set because trying to design the charging circuitry and weatherproofing the solar panel and finding all the necessary parts would just be too much and too expensive. And the same for the motion detector. Since the circuitry is so complicated, I modified a motion detector kit that I already had to use just the infrared sensor and amplifier portions of it. But the rest of the circuit, including the controlling transistor and timer and other portions, I designed myself. And because there wasn't enough voltage to drive the motion detector, power it off the solar light, or the solar panel, I actually had to include a 9-volt battery that would power it separately. But since the motion detector and control circuitry is the only thing that runs off the battery, I expect the battery to last for quite a while since the lights are still solar powered, and they are what uses most of the power. And also another major challenge is that the kit was designed to power a buzzer when it was triggered, but I wanted to power lights, and so that means instead of a second or so pulse that the kit provides, I need a minute or so pulse to turn the light on. So in order to fix that, I needed a timer. And I picked the LMC 555CN because it's very cheap and easy to use, and I can run it off the voltage that the solar panel provides. Also, another problem with my design is that in order to actually start the timer, I need the voltage to drop, but there's a spike in the voltage that comes out of the motion detector whenever it's triggered, and so in order to invert the signal, I need another integrated circuit, and I picked the CD4077BE XNOR gate. And so this is my schematic of the entire circuit. You can see on the left is the schematic that came with the the motion detector, and on the right is my circuit that I designed. And as you can see on the motion detector circuit, I'm not using the sound generator portion, which is on the bottom. And on the right, you can see on my circuit the timer and inverter and control transistor portions diagram. So my materials I used, I have my solar panel with the charging circuit and batteries built in. I've got 3 solar spotlights that came with the solar panel as part of a solar lighting kit. And I've got my motion detector kit, which triggers the buzzer, and these are the parts that came with it laid out. And I've got my 2 controller ICs, a board that I used to solder the circuit on to actually put it together. And I've got some fittings and a box for actually mounting the lights and to hold the electronics. And so the assembly. So first I breadboarded it, so you can see this is it set up on my electronics kit, and once I had the bugs out and got it working, I then soldered it, and as you can see on the left is the finished circuit boards. Mounted on the top is the motion detector board, and the back is the portion I designed. and then I installed it inside a box and mounted it outside. And this is a picture of me with the finished product. So I also did some calculations with it. So I did a budget. So I found that overall the cost added up to about $55, which is still close enough to my original budget plan. And I also did some cost comparisons with similar lights. I have a non-solar security light and a solar security light, which I'm comparing with. And unfortunately, I had problems finding lights for comparison with similar brightnesses, and mine's rather dim, but it's good for comparison in terms of the cost. So as you can see, the non-solar light is the same price, but it plugs into the wall, which means that it uses more power and therefore eventually will cost more. And it's also brighter though, which is an advantage that someone offsets that. And I've got a solar security light I'm comparing with, which is considerably brighter, but it also costs more. And I also did some similar comparisons in terms of energy. So I'm comparing with the same two lights. The non-solar security light uses 20 watts, which does add up over a few years, versus my light only requires the very minimum amount of power needed to recharge the 9-volt battery earlier, which I spoke of. And the solar security light doesn't require any power. Comparison one. So what's next? I may make some future improvements, including installing the third light. You may have seen in the materials picture earlier, there are actually 3 lights that came with the kit, but due to the way my mounting hardware worked out, I was only able to mount 2 of them. And that wouldn't be too hard. All I really need to do is buy some more mounting hardware and plug it into the connector on the box. And may modify the circuit so that the motion detector is powered directly from the solar panel instead of from the 9-volt battery, which would eliminate the need to replace the battery occasionally and make the energy usage 0. And eventually may integrate it with a possible future home security system if we install one. And so the significance of it saves energy. That's the most important part. It helps keep our home safe. It's much easier to customize and more flexible than a store-bought version. And it was a very fun experience. I learned a whole lot about electronics. And these are my resources. Thanks especially to my dad for some valuable electrical engineering consultation, without which I might not have gotten the circuit to work. And I guess with that, thank you for watching my presentation.